Let's say that you have given an exam or a test, and after the test or an exam you get the results obviously, and you have just received your report card. Let's say about you have taken your exams and you have the report card now, and in report card you will see the subject name and the marks. Like, let me draw it first. Let's say this is the report card, and let's add some subjects like physics, chemistry, biology, and maths. Okay, let's say suppose you have taken 75 marks in physics, chemistry 78, 80, and maths 84. Now I want you to focus on these subjects names and numbers. Like, you have taken 75 marks in physics, 78 marks in chemistry, 80 marks in biology, and 84 marks in maths. Now let's say if I remove any number like 75, and physics has no numerical value, you can tell how much marks you got in physics, right? And let me just undo it. Now if I do the same thing in physics, now there is 75. Now 75 number has no meaning because you obviously don't know in which subject you got the marks. Like 75, there is no subject marks. You can tell in which subject you got the marks. So in order to convey meaningful information, you need both the subject name and the marks you got it. And let us consider another example. Like, for example, if you're trying to find your friends a new address, let's just suppose the address is like apartment building. Let's say the apartment building is like 4, and the room number is the let's say the room number is like 14. Now this apartment building 4, it tells us that this is the fourth apartment building, and the room number is 14, that your friend is living in the fourth apartment building, and in that fourth apartment building the room number is 14. And let's again do the same thing. If I remove 4, it doesn't make any sense. You can tell in which apartment building your friend is living now, but if I remove the apartment building, you just can't tell what 4 is conveying the information about. So this is a general real life example, everyday life examples. You need something, you need a numerical value and some category in which you are trying to convey the information. The same goes for physics. Physics, is the understanding of the natural world. So how do you understand the natural world? You basically derive equation. How do you derive equation? Well, obviously with the tools of mathematics. But even playing with numbers, you cannot get any meaningful information. You need something. You need a uh, standard measurement, a physical measurement in the physical realm, in the physical world, in order to convey a meaningful information. Like, you in mathematics you can say 5 minus 5 equal to 2, but in real world if you are trying to calculate something, you need a standard of measure. For example, 5 meter minus 3 meter, you get 2 meter. If you remove the m from it, oh, sorry about that. Okay, okay, let's do a 5 here. If you remove the meter from it in physics, in the physical world, you just can't tell what is it's conveying the information in the real world. It might be in feet, it might be in kilometer, it might be in miles. You just can't tell about it. So that is why we are studying these physical quantities. These are called physical quantities. So what is basically a physical quantity? A physical quantity is anything that can be measured quantitatively in terms of a quantity is called a physical quantity. We need physical quantities in order to convey a meaning in the physical world. That is why physics is useful, because of the physical quantity, because of physical quantities. And the whole foundation, the whole basis of physics is laid upon the physical quantities. So let me just write the definition of physical quantities. You can say physical quantity as anything that can be measured quantitatively in terms of quantity. Let's say in terms of quantity is a physical quantity. It's a physical quantity. And in physical quantity you have two things that are combined to give a meaningful information. We have You have the obviously the numerical value, and then you have the unit. Numerical value meaning any number, like we have here 75, 78, 80, 84, any number value. And then you have the unit, and the unit is the standard of measurement through which you compare the results. For example, you have the meter. You have, for example, in terms of length we are talking about, we will use the meter m. In terms of mass you are talking about kilogram, kg. In terms of time you are talking about the second, etc. And to tell you more about it, I have some examples here. Let me just paste it. Okay, now we have these physical quantities, examples. First, let us focus on the first example. This package weighs about 500 grams. It's just conveying the information that the package is 500 gram. Let me just draw. Okay, it's saying that the package weighs about 500 grams, and you can now see that 500 is the numerical value and the g, gram, is the unit. You can also say that it's zero point 0.5 kilogram, because the SI unit for the mass is kilogram. And we have then the car is traveling a distance. The car traveled a distance of 500 meters. You have a car here. Please just don't mind my drawing. We have a car here, and okay, we have a car, and it has traveled a distance of 500 meters. And here again 500 is the numerical value, m is the unit. So basically they are conveying a meaningful information. It talks about the package of 500 grams, the car has traveled a distance of 500 meters in terms of length. Then the piston exerts a force of 500 newton, and then we have a time recorded by the stopwatch is 30 seconds. Okay, just draw the stopwatch. The stopwatch has recorded a time of 30 seconds. The same 30 is the numerical value, S is stand for the second, it's the unit, and today the temperature was recorded as was 302 Kelvin. Now here we have Kelvin, which is the SI unit of the temperature, but in terms of Celsius it goes around about it is around about 29 degrees Celsius Kelvin. Now here you can see that if we for example remove any of these, you need to understand it in physical quantities you need numerical value and the unit to both exist in order to convey information. For example, I remove G. Now it says about the package is 500. You just can't tell how much the package is. You need a unit to exist to tell you about it. In the same way, if I remove 500, you just cannot tell how much the package is weighing. We know the unit, we know the standard in which we are measuring, but you don't know the numerical value of it. So it also becomes useless. The same goes with every single example of it. So these are the physical quantities. You need numerical value and a unit in which you are measuring something. And there are two categories in physical quantities. We will talk about that now. Physical quantities are divided into base quantities and derived quantities. Base quantity, oh sorry about that, based not based, it is base quantity. Base. So what are the base quantities? These quantities are distinct quantities and they are chosen by conventions and they are used to derive other quantities. These are base quantity. These are the base through which all other quantities are derived. So let me just write it down. Just the main points, they are distinct. They are distinct. Chosen by convention. Chosen by convention meaning that's how the way they are done. Like in meters you were first a meter was just a I think the platinum bar, and now the meter is now defined in terms of the speed of light. We will talk about the meter, how meter became a meter in the next future videos. So let me just go through the simple explanation of all these. um, Chosen by convention and are used to derive, sorry about that, are used to derive other quantities. quantity. These are the base quantities, and the second is the derived quantities. As from the word derived, you know that these quantities are the quantities that are derived on the basis of other quantities. Mostly they are base quantities, so they are derived from other quantities. They are derived from other quantities, mainly base quantities. Oh, and sorry about the I forgot about the example of it. The base quantities are meter, length, we have mass, we have kilogram, kg, and then you have time, we use second, s, and then we have temperature, we use Kelvin, K. And there are all other base quantity, but these are the main we use. Derived quantities. Derived quantities, you have velocity, we have acceleration, okay, and you have force. You calculate in newtons, Newton n. Now here, how do you how do you make derived quantities? Let's say about velocity. You know, velocity is a distance divided by time, d by t. So what is a distance? Distance is like length. Here you have meter, m. We have time. Time from base quantity, it is measured in second, and then we have second. So it is v equal to ms minus 1. The same goes with acceleration. The same goes with force, Newton. So I hope you have found this video informative. So to conclude, that all the foundation of physics is laid on the physical quantities, because we are talking about physics, we are talking about the real life scenarios. So we need a standard to which we can convey our calculation to be more meaningful. We need a standard in which we can measure something. That is why we use physical quantities. So I hope you found this video informative, and if you have found it informative, then like this video and subscribe to my channel for more future videos. Thank you.